Hello, mathematicians, puzzlers, and other curious people. Today I have for you a whopper of a problem, if you know what I'm saying. There's a puzzle going around right now as of this particular week. Let's see, today's the 14th of April in 2020. And this isn't the exact puzzle, but it might help you out with figuring it out. So this is summation notation. And what we're doing here is taking the sum as our index variable. Here we used I, goes from 1 to 9, of negative 1 to the power I times 6 factorial times 6 over 5 to the power 1/2. Now, how are we going to do that? Well, the first thing I notice is that what we have here doesn't have any variables in it at all. So that's just some constant. So I'm going to do a side calculation to simplify that. And I'm going to color code because it's always better with color coding. So let's do a side calculation. Okay, the first thing I notice is this 1/2 power. Well, that's just the same as a square root of whatever that power is being applied to. That's just what a fractional exponent is. Now, what can we notice next? Well, I notice we've got 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 times 6 over 5 factorial, which is 5 times 4 times 3 times 2 times 1. One thing you might notice there is we've got a heck of a lot of repeated factors. So an easy way to write this is to say, okay, 6 factorial is really, like I said, 6 times 5 times 4 times 3 times 2 times 1, and 5 factorial is really 5 times 4 times 3 times 2 times 1. So another way you could write 6 factorial is 6 times, for all this there, wrap it up in 5 factorial. So let's scoot this down a bit, and let's plug that back in and see what we can do with it. So what I see here is if we rewrite that 6 factorial as 6 times 5 factorial, then I notice that we've got a 5 factorial and a 5 factorial. We can divide out the both of them. So now what we've got here is the square root of 6 times 6. Which is just the square root of 36, which is 6. Okay, so that part is easy so far. And now we have a nicer way we can write this particular factor, because that just simplifies out to 6. And we can copy in the rest of the problem around it. Okay. So now let's take a look at this negative 1 times I part. That's going to change because it's got our index variable in it. So let's take a look at what happens as this goes through. By the way, this sigma for summation, that means we're going to be taking a sum after we evaluate this expression for the 9 different values of our index variable. So let's set this up in columns. So our index variable could be 1, 2, 3, 4, 5, 6, 7, 8, or 9, and we're going to have to add all those up. Okay, so let's find out what negative 1 to the power I times 6 is for each of those. So if we've got negative 1 to the power 1 times 6, and then we'll just continue that. I want more space here. Yeah. Let me just space that out a little bit better. Was trying to save space, but it didn't work out so well. Okay, so there we have that we've got -1 to some power times 6. That's going to be a repeated thing happening. So here, it's going to be the 3. And we can see where this is going to go. So again, we're going to go through, and for that index variable in each spot, just plug in our value of it based on which term of the summation this is. And all a summation means is we're going to be calculating values for all these things and then adding them up. Okay, so now we need to say, okay, -1 to the power 1. Well, anything to the power 1 is just itself, and then -1 times 6 would be -6. Now -1 to the power 2. Well, a negative times a negative goes positive, so we're going to have there 1 times 6, which will just be 6. -1 to the power 3 will be -1, times 6 will be -6. -1 to the power 4 would be 1, times 6 is 6. -1 to the power 5 would be -1, times 6 is -6. And so on. So let's see, that's even. So 1 times 6 is 6. That's odd. So -1 times 6 is -6. Even. So 1 times 6 is 6. Oh, excuse me. Allergies, right? And then odd power, so negative times 6 gives us -6. Now we have to add all those up. So let's see. -6 plus 6 is 0. And so on. So we've got a bunch of things here that cancel, and that's not a coincidence. It's because we took the same thing, only had that -1 to our index power term alternating it between negative and positive. So our sum here is just 6. So that would be my final answer. Now, was there a quicker way we could have done that? Well, sure. We could have noticed that each odd and then even pair would do that same thing. Negative and positive cancel to 0 when we do the summation. So then, for example, if we were going to take a very large power, like if we were taking the sum as our index variable goes from 1 to 327, well, we could still say, okay, the first 326 of them are going to come out to 0 because they're going to pair up odd and even to cancel out. And then that last one will still give us a 6. So that's the trick, to notice if this right here is odd or even. Now, if you happen to go looking for the puzzle that, again, is a whopper of a puzzle, pay careful attention to anything else that might be in the expression along with the summation. And remember, the numbers aren't exactly the same, so don't just copy my answer. It's not going to work for you. So now that you can see how to do this, go have some fun. And but for now, I'm going to say, calc you later.